Now we will see how to create a copy of a original array. Earlier we just have created a view that just is not a copy. A view is another name. Simply in the bottom statement is, bottom line is, it's another word or another identifier to the original array. But here we'll also be able to create a different copy. When you create a different copy, the changes that you have made in B will not affect in A, where A is the original array, B is a created copy. And similar to the view, either you can directly copy array A into B completely, or a slicer portion of A can be copied into B. How will you be able to do it? Now what I need to do is, I just need to create array of A. Now I need to take B. B is equal to A of dot, as I said, copy. This copy function will copy the array of A into B. Now here A remains the same, B will just be a copy of A. A memory image will get created, separate memory copy will get created. So here what am I doing is, I just am not directly copying entire array. Here when you do not pass any parameters, total array A will get completely copied. But here what I am doing is, I just am creating a sliced copy of A. What is sliced copy of A? Here A is a 3D array in which I just have specified the page. Which page? It is the first page. This is 0, 1, 2. In the specified page, in the first page, what I'm taking? The total 0th row. I just am taking 0th row. This is 9, 10, 11. So B is equal to just 9, 10, 11, the first row of the first page. Right after which I would want to update B. How? When I print B, obviously 9, 10, 11 will get printed if you print B here. But here what am I doing is, I want to update B. B of 1. What does it mean? In B is simply a vector here. In the vector, it is expected to be at 0th index, first index and the second index. At the first index, we do have 10. What we are doing? B of 1 is equal to 999. What does it mean? We are replacing the element which is at the first index with 999. So 999 is going to replace 10 here. So what is the outcome? 9, 999, 11. So the outcome of B is equal to 9, 999, 11. Now here when you want to print A, obviously the actual array of A will get printed because it is unaffected and untouched, since all the modification actually are done on the copy of A which is named as B. Now array, when you print A, the actual original array of A which is unchanged will be printed because A is not at all changed or manipulated. This is how we can create a copy of A. All the slicing can also be applicable on the copies. Next thing is how we will be able to change the data type of an existing array. Now understand, when you create an array, you will be able to specify the data type. You will be able to specify the data type. Right after you specify the array and you want to change the data type, what actually is the method? There is one method is called as type. This as type method, whatever the type that you want to cast will be passed here as a parameter, will be able to change the original data type of an array. How we just are going to do it? Let us have a look at. Now, have a look at this. I just have created A, NP array 1, 2, 3. Here I just am specifying the data type here. Now, every array during the creation will also be able to specify the data type. D type is equal to NP int 32. What does it mean? Integer with 32 bits will get allocated. There are several data types which we have discussed earlier in one of the previous sessions. Int 32 is going to allocate 4 bytes for an integer. Now what is specified? All these values that I passed into the array is of a type integer of 32 bits. Okay, this is equal to 4 bytes. Now right after which when I print this, obviously this will get printed output 1, 2, 3, and I also am printing a.d type. What am I printing? In printing, I just am printing A, that is the first parameter. Second parameter is I just also am printing a.d type. The object of array A, what is that? 1, 2, 3 will get printed. This is the object of A. Right, done. What is the data type? Int32 is the data type that is being printed. Now I would want to change this data type into some other. Now how will I be able to do it? Now for that, as I already told you, we just need to use AS type. AS type with a change data type as a parameter. When you use, you will be able to change the data type of A. For that, we just need to take the array object which is A. I will write it here. A dot as type. Here again data type you need to specify. Okay, this is the syntax. Now in which A is the original array object, right, done, original array identifier dot as type np dot float 64. np dot float 64 is the data type that I would want to convert A into. Now what is float 64? A float data type which will allocate 64 bits, 8 bytes to the array, 8 bytes to each data. Now when you print, what is going to be printed here? 1 dot, 2 dot, 3 dot. Here 1 comma 2 comma 3, these are the plainly the numbers. Okay, when you say 1 dot, what exactly it means? It's a floating point number. It's going to take the decimal values, right? So the type has been casted. This is how type casting is going to be done in the NumPy arrays. For that, the main the main method is AS type. The parameter should be the data type that you want to convert it into, cast into. Okay, it's just for that you just need to go through all the total table that I just explained in one of the previous sessions. The total data types, but some are not compatible to each other. When you want to change the data type of an array into an incompatible one, how would we do it? Generally, if the data type is not compatible, it is going to raise an error. How that's going to happen? Let us have a look at. Here what is it? Simple. I just have C is equal to, I just have taken one more thing. Have a look at this carefully. B is float. Total A has been converted to a floating point numbers. And here I also am taking C. This is B. B is equal to the changed A as float value. Now just I'm taking C. This C will be is Boolean version. Okay. So what I'll do is A dot as type BOOL. In BOOL only Boolean values will get stored. What are those Boolean values? Only 0 and 1. Are we clear? So anything other than 0 will be true. Anything less than 1, anything other than 0 it is true. Anything less than 1 will be equal to false. Okay, so here since it is 1, 2, 3, the total values of the array will be equal to true, true, true. Once again, what is the Boolean value? Understand carefully. Integers will start from so on, 0 to infinite. But generally it is not infinite, it is bound by some value with respect to the number of bytes that are being allocated, 32k or something else. So A to so on. In a Boolean values, there are only two possible discrete values. What are those? One is false and one more is true. So which value will be interpreted as false? Any value other than 0 will be interpreted as false. Okay. Any value which is less than 1, obviously 0, will be interpreted as false. Any value other than 0 will be interpreted as true. Any value other than less than 1 will be interpreted as false. Bigger pardon. Thank you so much. Now, specifying the data type during the array creation, I already shown you this. Specifying the data type during the creation, when you create an array, you also will be able to specify the data type that you would want to have. Simply you just can pass the object into an array, write done, just using a list here. Now write done, when I specify d type is equal to np.int is 64 or whatever the data type, this array's data type will be defined as the data type that you have given. Okay, I hope you got the point. the creating an array of floats will be b is equal to np.array 1.1, 2.2 to 3.3. Here you should be able to specify d type is equal to np.float 32. What is the float 32? For every floating point number you will be provided with 4 bytes. Okay, so data type, when you print data type, output will be 1.1, 2.2, 3.3. Here what you're printing, in printing you are printing two things. One is the object, second thing is the data type that you passed. Data type is float 32. Here data type is 64. What you're printing here, A and data type. A is 1, 2, 3, data type is 64. Okay, now how we will be able to convert the incompatible types? Sometimes some data types cannot be converted into each other. Why? These are actually incompatible to each other, mutually are not compatible with each other. At that time, what would be the possible outcome? Let us understand. Here, when converting types, NumPy handles some cases differently. For example, let us see. If you convert floats to integer, it truncates. For example, there is a 2.9 value. There is a value which is 2.9, which is a floating value. Right now, I want to change this into an integer value. How would I be able to do it? When I change this data type from float 32 to int 32, it will round down. What is round down? It will be 2.0. Are we clear? Only this part will be taken, this part will be discarded. It just will not round off, it just will round down. What is rounding off? Rounding off is to the nearest value, but here it just rounds down. Okay, so here only the value which is before the decimal point will be considered, the value which is after the decimal point will be discarded here. So understand carefully, A is equal to np array 1.9, 2.1, 3.7 and the data type is np.float64. This is the data type. Right then, B is equal to A as type np.int32. The data type is being converted into integer. Now, when you print it, what will get printed? 1, 2, 3. As simple as this, because it just will round down, it will not round off. It truncates to the rounding down value. Okay. Now, a string to integer. Here, this is a string 1, 2, 3. Data type is np.string. This is a string value because anything which is enclosed in the double quotations is considered to be as a string. Now, when I would want to change it to the integer value, it will be perfectly fine because integers of 1 and 2, 3 are perfectly taken. Now, D is equal to C dot as type np.int32. What's going to happen? Obviously, D will get printed. What is D? D simply is 1, 2, 3. Okay, it is no more a string. These values are no more strings, rather these will have some substantial numeric values. And the next thing is invalid conversion. I am going to show you one invalid conversion here. That is, for an example, there is 1, 2 and 3. This cannot be converted. 3 is what? 3 is alphabets. It cannot be converted into integer, right? Okay, so what we'll do is, when we say dtype np.str, obviously, it is of str string value because it is getting enclosed in double quotations. Okay, right then when we want to convert the type of a string array into an integer, this becomes incompatible. The current array is incompatible to string because, integer, because this 3 cannot be converted into integer at all. So it is going to raise an error. What I am saying, f is equal to e dot as type np.int32. This is going to raise an error because 1 and 2 can easily be converted, but 3 cannot be converted. 3 is alphabets, a collection of alphabets. So the system is going to throw an error, system is going to raise an error. This is how incompatible errors, incompatible data type conversions will be handled by the Python program, NumPy libraries. Thank you so much.